Here's an example of sine inverse of sine of a fraction. Let me write it so you can read it a little better. It says sine inverse of sine of negative 3 pi over 4. Okay, so how do we do it? Well, the steps, if you go to the notes, the steps tell you, step number 1, determine is this an angle or an answer. So you got to figure out if the thing you're plugging in is an angle or an answer. Remember, for regular sine functions, or cosine or tangent, we plug in an angle, we get out an answer. For an inverse sine function, we reverse that, we plug in an answer, we get at an angle. So this right here is inside, it's inside of sine function, right? It's inside of this sine function, so it must be an angle. Step 2, check the limited domain. So the limited domain for sine of an angle is negative pi over 2 to pi over 2. You'll see that on the notes that I gave you, that I sent you, negative pi over 2 to pi over 2. So if we, is it within there? If I go like positive pi over 2 to negative pi over 2, here's 0 in the middle, the question is negative 3 pi over 4 there? No, 3/4 would be, back here somewhere, right? It's, here it'd be like negative 1 whole pi, right? This is half a pi, negative 3/4 of a pi, negative 1 whole pi, even further negative, right? So no, here's the zone, here's the domain, the limited domain is between negative pi over 2 and positive pi over 2. Negative 3/4 is outside. He's outside of that limited domain. So that means we're not allowed to just cancel and go, oh, they're just inverse functions, so they just cancel and the answer is negative 3 pi over 4. No, we're not allowed to do that. You're only allowed to do that when it's within the limited domain. If that was within the limited domain, if it was some angle between negative pi over 2 and positive pi over 2, then yeah, you could just cancel and say the answer is negative 3 pi over 4. The problem with that is, you might say, why can't we? They're inverse functions. Yeah, but they're only inverse functions within the limited domain, right? Sine inverse is limited. Remember the graph, sine inverse is only from here to here, negative pi over 2 to positive pi over 2. That's where sine inverse is limited. So this angle is outside of that range. So we can't just cancel them when they're outside of that range. Well, then what do we do? Well, it says if it's outside, if you look at the notes, here I'll look at the notes with you real quick. So here we go. So step 1, figure out if it's a angle or answer. We did, it's an angle. Step 2, figure out if it's within the limited domain. There it is, negative pi over 2 pi over 2. No, it's outside. If it is within, well, that's not us. If it's outside, that's us. And it's an answer. No, we don't have an answer. We have an angle. So step 5, if it is outside and it's an angle, well, okay, that's us. What do we do? Then we cannot just cancel. We already said that. But there will be still an answer. It won't be D and E. It's not. Why is it not D and E? Because it's an angle, and no matter how big an angle is, we can always add or subtract 2 pi full rotations until we find where it is. There's never a problem with angles. Angles can get as big as they want, right? They just keep going around the circle. So we can figure this out, that it will have a spot where we can get an answer. We must work out the problem starting on the inside. That's the deal. So we start here on the inside, and we just add and subtract full rotations 2 pi's. So that's how we do it. Let's get back to it. So bringing the problem on down here. Here I'll say. So we're on step 5 then. Start on the inside because it's an angle and it's outside the limited domain. So that's going to be sine inverse of sine of minus 3 pi over 4. So start on the inside. So here is the inside. So bring that down. So in other words, just figure out the sine of negative 3 pi over 4 first, and then finish the problem from there. How do we find the sine of negative 3 pi over 4? Remember, with negative angles, we always just add 2 pi. right? Just add a full rotation because we have to find that angle on the unit circle, and the unit circle doesn't list any negative angles. So it's better to just add 2 pi, make it a positive angle. Remember, the unit circle is just that, it's a circle. So negative 3 pi over 4, which is actually right there, negative 3 pi over 4, is the same thing as some positive angle. So here's my main point. I'm probably getting off track. Whenever you're somewhere on the unit circle, if you add 2 pi, if you go around one full time, you're back to the same spot. That could never change an answer, right? You can add as many full rotations as you want. You're back to the same spot. So if we take minus 3 pi over 4 and we add a full rotation, we're still going to be at the same spot. It won't change the spot. So how do you add 2 pi? Put this over 1, top and bottom by 4, common denominator. Negative 3 pi over 4 plus 8 pi over 4. What is that? Positive 5 pi over 4. Okay, good. So this becomes the sine of positive 5 pi over 4. That's the same spot on the unit circle because we just added one full rotation. So we're back to the same spot. So let's go look for the sine of 5 pi over 4 on the unit circle. So 5 pi over 4 on the unit circle. Where is 5 pi over 4? It's right here, as I was saying. There it is. This is the cosine and the sine. We're doing the sine. Sine of 5 pi over 4 is negative root 2 over 2. Negative root 2 over 2. So let's go back there. So this is negative root 2 over 2. That's the sine of 5 pi over 4. Now, that's the inside. All of that's the inside. Let's now bring down this outside piece. So it becomes the sine inverse, right? That was sitting on the outside the whole time. We just started on the inside. The inside became negative root 2 over 2. You good with me so far? So one more time, let me make sure this is super clear. This was the inside we did. This sine of negative 3 pi over 4 was the inside. We did it by adding a full rotation, so we got the same spot. Went to the unit circle, found the sine of 5 pi over 4 is negative root 2 over 2. So that's the inside answer. Now finish the problem. Now finish the problem. Okay? How do I finish the problem? I've got to find the sine inverse of negative root 2 over 2. Remember, this is an answer, and we're looking for an angle. So we're looking for an angle that, let me make a little more room here, this is kind of bothering me. Now finish the problem. There. So we're looking for an angle whose answer on the unit circle is negative root 2 over 2. So I'm going to go back to the unit circle, and I'm going to look, and I'm going to find where the answer is negative root 2 over 2, and grab the angle going with that, because this is sine inverse, right? So that means you put answers in, and I'm looking for an angle. All right, let's go back to the unit circle. Here we go. So, well, it's right here. I mean, we just got it. Sine negative, so there, it's just 5 pi over 4 again. No, I hope you know that's not the truth. Why? What's wrong with that? Remember what we learned right here about sine inverse and tangent inverse. Only use quadrants 1 and 4. See this big arrow thing here? Right? We can only use quadrants 1 and 4. We can't go over here in quadrant 3 or any quadrant 2 stuff. Not allowed for sine inverse or tangent inverse. We can only look in quadrants 1 and 4. So I have to look in quadrant 1 or 4 for where I've got a sine of negative root 2 over 2. So this is cosine sine, cosine sine, cosine sine. I can't even read these. Cosine sine, cosine sine, cosine sine. There it is. Negative root 2 over 2. The sine is negative root 2 over 2. There. Okay, so what's the angle? 7 pi over 4. That's our answer. Hold on. If we take that back, we're going to make a mistake. Here's the other note. Angles in quadrant 4 are changed to negative. And see this arrow right here? This arrow, let's trace this one back here. becomes negative pi over 4. This one is negative pi over 4, not 7 pi over 4. I can't use the 7 pi over 4. That's the other weird thing. There's these two weird things you got to keep in mind when you do sine inverse and tangent inverse in quadrant 1 and 4, especially in quadrant 4, the answers are changed to negative. You give the negative version. It's the same spot, right? This spot is negative pi over 4 because it's the same as this spot, right? That's positive pi over 4. This is negative pi over 4. But it was also listed as 7 pi over 4. Yeah, but they don't want you to say it that way. They want you to give the negative version. So negative pi over 4. So we go back and we say the angle is negative pi over 4. And that's the answer to the question. Negative pi over 4. That's how we have to say it. So there we go. That was a pretty tricky one. So again, we cannot just cancel these out because this guy is an angle, but it's not within the limited domain, negative pi over 2 to pi over 2. So instead, we had to start on the inside, change that by adding a rotation to get the same spot, went to the unit circle, found the sine of 5 pi over 4 is negative root 2 over 2, and then finally sine inverse of negative root 2 over 2, went to the unit circle. That was my answer, looking for an angle, but when I went there, I had to look only in the first and fourth quadrant, and the fourth quadrant had to be changed to negative pi over 4. That's pretty tricky.